Hello, good day, everyone. My topic is all about software architecture. So, now let me proceed or start with an introduction. Software architecture refers to the fundamental organization of a software system and the principles that guide its design and evolution. It encompasses the structure, behavior, and interaction of system components, as well as the constraints that govern their implementations. In essence, software architecture provides a blueprint for constructing and maintaining complex software systems. This means that software architecture is like the skeleton of a building. It is a plan that shows how all the pieces of software fit together and work. It includes how they interact, what they do, and even the rules they follow. Basically, it is the roadmap for building and keeping complex software system running smoothly. So now we will have the brief history. So the concept of software architecture emerged in 1960s and 1970s with the advent of large-scale software system and the recognition of the need for systematic approaches to their design and development. Pioneers such as Fred Brooks, who wrote the mythical Man Month, and David Parnas, who introduced the notion of modularization and information hiding, laid the groundwork for modern software architecture principles. So, in the 1960s and 1970s, people realized somehow, big software system needed better design. So, this led to software architecture, wherein Fred Brooks and David Parnas had key ideas like breaking systems into parts and hiding how they work. So, in the 1980s and 1990s, the field witnessed significant advancement with the development of architectural styles and patterns, such as the client server architecture and the model view controller or the MVC pattern. The rise of object oriented programming in the component based development further influenced the evolution of software architecture concepts. So, it is then that later in the 1980s and 1990s, new styles and patterns emerged, like client server and MVC. Object oriented programming as well, and components also changed how we design software. So, what's the importance of this, especially in terms in software engineering? So, software architecture plays a pivotal role in software engineering by providing a structured approach to system design and development. Some key reason why software architecture is crucial include number one is facilitating communication, enabling scalability and maintainability, managing complexity, mitigating risk. So, we will proceed first with the facilitating communication. Software architecture serve as a common language for stakeholders, enabling effective communication and collaboration among developers, designers, and project managers. So, software architecture somehow helps everyone involved in a project talk to each other better. It is like using a common language that developers, designers, and project managers all understand. This makes it easier for them to work together and get things done efficiently. Now we will go into the second one, which is the enabling scalability and maintainability. A well-designed architecture allows software system to scale gracefully and adapt to changing requirements without compromising performance or reliability. It also facilitates maintenance and evolution by encapsulating complexity and promoting modularization. So, a well-designed architecture allows software system to scale gracefully and adapt to changing requirements without compromising performance or reliability. It is also facilitate maintenance and evolution by encapsulating complexity and somehow promoting modularization. The third one is managing complexity. Software architecture helps manage the inherent complexity of software system by breaking them down into manageable components and defining clear interfaces and interaction between them. So software architecture simplifies the complex software by breaking it into smaller parts and making sure that they work together smoothly. It is like somehow organizing a messy room into tidy sections so everything is easier to find and use. The fourth one is mitigating risk. By identifying and addressing architecture risk early in the development life cycle, the software architecture helps minimize project risk and ensure the successful delivery of high quality software system. So by mitigating risk in software architecture means finding and fixing problems early. This helps make sure that project goes smoothly and produce top-notch software. So the next one is application in the software development. So in software architecture finds application across various domains and industries including. So number one is the architectural styles and patterns. Second is design and documentation techniques. Third is the case studies. Fourth is the tools and frameworks. So we will go first with the first one, which is the architectural styles and patterns. Common architectural styles and patterns, such as layered architecture, microservices architecture, and event-driven architecture, provide blueprints for designing software system that meets specific functional and non-functional requirements. So there are different ways of designing software, like layered of microservices, give plans for creating system that somehow works well. The second one is the design and documentation techniques. Techniques a unified modeling language or the UML, diagrams, architectural decision records or ADRs, and architecture reviews facilitate the design, documentation, and validation of the software architectures. So therefore, methods like UML diagrams or architecture reviews help make and record software plans. And now the third one is the case studies. Real world case studies illustrate how software architecture principles are applied in practice to address challenges and achieve business goals in diverse contexts. So, real example shows how software plans solve problems and meet business needs. So, last but not least is the tools and frameworks. A plethora of tools and frameworks such as Enterprise Architect, Archimate, and Balsamic support software architects in modeling, analyzing, and communicating architectural designs effectively. So, programs like Enterprise Architect help architects make and explain their software designs better. So, in conclusion, software architecture serves as a foundation for building reliable, scalable, and maintainable software systems by providing a systematic approach to system design and development. Software architecture helps mitigate risk, manage complexity, and align technical decision with business objectives. As software systems continue to grow in complexity and scale, the role of software architecture in shaping the future of software engineering remains indispensable. So, thus, or in short, software architecture is like the strong base for creating good and manageable software. It helps reduce problems, handle complexity, and ensures technical decisions that match business goals. So, as software gets more complex, software architecture stays crucial in shaping the future of how we build things, especially how we build software development or how we able to develop software.